Paper 2, question 23. Dan does an experiment to find the value of pi. He measures the circumference and the diameter of a circle. He measures the circumference, C, as being 170 millimeters to the nearest millimeter. And he measures the diameter, D, as being 54 millimeters to the nearest millimeter. Dan uses pi equals C over D to find the value of pi. Calculate the upper bound and the lower bound for Dan's value of pi. What that basically means is whenever you measure something, there is a natural tolerance. The fact that he measured C as being 170, it could have been just above or just below it. He measured D as 54, it could have been just above and just below it. Now, how far you go up and down is basically halfway between it and the next value. So above this is 171, and below this is 169. Above 54 is 55, and below it is 53. And you basically go halfway between 53 and 54, halfway between 54 and 55, and so on, to figure out what the biggest and smallest values of C could be, and the biggest and smallest values of D could be. So here, halfway between those two is 170.5, so that's the biggest C can be. And that is this, and then halfway between those two is 169.5. That is the smallest C can be. So if you're looking at C alone, that is its upper and lower bounds. For D, 54 between 54 and 55 gives us 54.5, and between 53 and 54 gives us 53.5. That is the upper and lower bounds for D. And the idea is you need to combine these bounds together for this formula, because if you're slightly out in one and slightly out in another value and you bring them together in a formula, then you could potentially be even more out in your answer. Now, here's where it gets a little bit tricky. Because of the fact that you have constructed, this formula is constructed with a fraction in it, C, the bigger C is, in terms of the upper bound for C, will contribute to the upper bound for the whole thing, because the bigger C is, the bigger the whole thing is. The smaller C is, the smaller the whole thing is. Whereas the bounds for D are different. Because you're dividing by D, the bigger D is, the smaller the whole thing is. And the smaller D is, the bigger the whole thing is. So what you look at here is, the biggest thing C can be contributes to this whole thing getting bigger. And the smallest that can be also contributes to the biggest, to the upper bound of the whole thing. So what you do is you plug these in and see what you get, and that's going to be the upper bound. Then afterwards, we take these two values. Smaller the top is, the smaller the whole thing is. The bigger the bottom, the smaller the whole thing. You combine those two in the formula and see what the lower bound is going to be. So for upper, plugging those values in, 170.5 all over 53.5. That gives me 3.187 as being the upper bound. For the lower bound, we have 169.5 for C, and for D we have 54.5. When you calculate those two, you get 3.110. That's the lower bound. So 3.110 or 3.11 is the lowest that it can be, based on this sort of tolerance of your measurement being maybe slightly out. And the biggest it can be is 3.187.